what surface area of that particular loop. That particular loop can be identified by the energy product. Energy product is what? BR cross HCR. What is BR? This much is retentive magnetic induction is called as BR. Then this is coercive magnetic field. Or coercivity, process is coercivity. This field, this much field, applied to retain the initial magnetic induction is called as coercive magnetic field. That coercive magnetic field HCR, and then retentive magnetic induction is BR. The cross product of that one may become what? Energy product of this material. This energy efficiency of this material can be, magnetic energy efficiency of this material can be decided by this product. That's it. Then come to this diagram. Here we have the same diagram only, but the same diagram positive side, is divided into three different parts. Number one is taken as reversible wall displacement. Number 2 is taken as irreversible wall displacement. 3, domain rotation. Number 1, reversible. Suppose minimum magnetic field less than this is applied. Some disturbance may be there, if you release that applied magnetic field. The applied magnetic field removed means again the initial position will be retained. Okay, come to the second one. Irreversible wall displacement. Suppose somewhat that rotation crosses this particular point, then rotation reaches the halfway mark, suppose that halfway mark is reached, so what will happen? That even the applied magnetic field is removed, the initial position may not be retained, instead of that some residual magnetic induction may be there in the material. Okay, suppose that applied magnetic field is keep on increasing one particular point, for example this point, on this point this will become saturation. That means what? Magnetic induction may become saturation state, or intensity of magnetization reaching the saturation state of. That means what? Rotation permanently completed. The completed means what? Suppose this is the applied magnetic field direction. How many dipoles are there in the material? Every dipole becomes parallel to applied magnetic field. Every dipole becomes parallel means there no more process needed for that one. That material becomes stronger magnetic material. Even it is paramagnetic material, in the presence of magnetic material, that will become stronger that will behave similar to ferromagnetic material. That is what indicated by this arrow mark. Okay, that is what then given here. The movement of domain walls. Initially the magnetic field is applied, we can have the movement of domain walls. Then at last the maximum applied magnetic field, what will happen? Rotation of domain wall. At last it will be rotated by 180 degree. Rotation means what? 180 degree. Maximum of 180 degree. That is what given here. If the applied field is removed, the domains return to its original state is called as reversible domains. If it cannot be reached means that may become irreversible domains. Even when the applied field is removed, the domain do not come back to their original position is called as irreversible domains. When the field is increased, applied field is keep on increasing, the domain start rotating along the field direction. At last, for one particular maximum applied magnetic field value, it will be perfectly rotated. That means the rotated magnetic domains becomes parallel to applied magnetic field. That will be called as what? Domain rotation, last one. Okay, here already I said, the same thing. Hysteresis loss, we can measure the hysteresis loss of. Okay, first we have to understand what is the energy product. From that we can go for efficiency. At the time of rotation, some energy work is done, that work done will have loss of energy. Work is done, always the loss of energy is applicable. Amount of energy may be utilized for work done, for the rotation process, amount of energy, part of applied magnetic field, one part, it may be minimum or maximum, one part will be utilized for rotation process. That means what? By taking minimum part of energy, applied magnetic field, then some work is done in the material. That is called as, that work done is called as magnetization, isn't it? Okay, depends on that intensity of magnetization, the dissipation will be decided. That dissipation becomes loss of that material, loss of energy for that material. That loss is called as hysteresis loss. So that can also be identified from this particular hysteresis law. That's it. Okay, here